This is SciByte, episode 104 for October 1st, 2013. Hi, everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast, live over at jblive.tv on Tuesdays at 7:30 p.m. Pacific, 10:30 Eastern, and then fresh Wednesday mornings over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, what are we going to talk about today?
Today, we're going to take a look at sleeping away fear, lunar formation theories, neonatal hypoglycemia, sending messages to interstellar space, viewer feedback, curiosity news, and as always, take a peek back into history and up in the sky this week.
Holy smokes. Well, Heather, a special happy science to you. That sounds like a great lineup. Should we kick it off with, I don't know, the news?
Let's go.
All right, what are we going to talk about at the top here?
So, sleep and fear. There was a study that showed that exposing people to a memory over and over again while they slept was actually able to reduce that fear. So what they did was, how do you make someone dream about icky spiders or whatever you may fill in the blank here? They had 10 subjects, and while they were awake, they would receive mild electrical shocks while seeing two different faces and smelling something. So they'd smell like lemon, shock, and a face.
Whoa.
And then they smell mint and a different face with no shock. So only one of them was causing fear. So what they were able to do then was say, okay, now the brain is associating this face and smell equal bad. So then while they were asleep, they could be exposed to that smell. And so the brain is connecting them together. And once they were able to do it over and over while they slept, when they checked them again the next day, the response for the fear of that face and smell equaling shock, the fear was reduced.
So is it like it's like sort of using that built-in system where like when you smell something, it takes you back to a memory, only kind of using that to wash the fear out of you?
Yes.
Right,
they have daytime what they call exposure therapy, where you have a fear of something, and so we'll call it spiders. Just because I'm not quite afraid of spiders, but
I don't think
so I can talk about it.
Yeah.
Not enough so I can actually talk about it.
Yeah.
So they'll slowly introduce you to there's a quick picture of one. Here's more pictures, and it's just slowly expose your brain to this more and more so that it kind of deadens the fear.
No, the more I look at spiders, the more they freak me out.
Well, it's like a specific type of therapy.
Yeah, I follow.
So what they're thinking is this might be able to roll over into while someone's sleep. So it's kind of a way to expand upon that type of therapy. So
I love the idea of being semi-productive while I sleep. Not that my body isn't already being productive in its own little way.
Yes. But it's one of those things where you might be able to help treat phobias. Now, I know somebody who had a phobia of heights, and he went into this sort of, because it interfered with his ability to drive and going on an overpass or anything. And so he went to this kind of exposure therapy where they kind of helped him a little bit his way through it. So at least he could drive from point A to point B without making sure he had a specific route in mind. Saying, I can only take these roads. And so this kind of a thing would be able to roll over into while he was asleep, and it maybe make that therapy, go a little faster or be, better. And they were able to, it's like fear. How do you measure fear? Well, they did through small amounts of sweat in the skin, which is kind of like a lie detector test. And they actually did the fMRI, which if you were watching the video feed, you might have seen it. It's one of those functional MRIs where they can actually view your brain while you're thinking. So they can kind of see what changes or what's triggering off in your brain while you're conscious. They're able to see specific decreases in reactivity to those faces and odors while they were sleeping and with the amount of sweat on the skin. So it's interesting in this fact that they could actually use this to help people. And like you said, be productive while you sleep and be able to expand upon that kind of a therapy during a time where, hey, that's extra time for that kind of therapy, and you can do it when you're not trying to be very useful during the day. So your productivity is still a little higher. You're just being able to make more use of non-working time.
Yeah, interesting. Well, maybe it'll start. Maybe it starts there, and then you take it 50 years down the road, and you've got the Matrix, and you can learn kung fu in your sleep. Huh? What do you think, Heather?
Science is skeptical.
Oh, well, then why don't we take a quick break right there? And I want to remind folks, as the holiday season approaches, oh my goodness, I know, I can't believe it either that it's October. I'm not panicking. I'm not. No, me? Panic attack? No.
Not yet.
No. Well, actually, just a tiny bit, but that's just between you and me. Don't tell anybody. But before you do any of that shopping, or maybe just some general shopping, I want to remind you that you can support the Jupiter Broadcasting Network in whole by visiting our website and clicking down at the links at the bottom of our website. Tags your shopping session with our affiliate tag. But if you want to make it even easier, you can grab our Chrome or Firefox extension. Pow! Automatically tags your shopping session for you. That way you don't even have to worry about it. Plus, we include other countries. So Amazon has a bunch of different versions and a bunch of other crazy kids do, because apparently there's a different internet in different parts of the world. Whatever. We have support for that in the browser. We also just added woot.com to the browser extension. We just recently did an update too. So if you have our browser extension, you have to re-enable it, at least on Chrome. I just thought I'd make a mention, by the way. Just to remind folks, if you're going to be out shopping or somebody's going to be picking up one of them new Kindles, the new Kindles are here. It actually looks kind of sweet. It has a pretty nice display with 339 ppi, which is, that's really high resolution. It's going to make a lot of photographs look really good. If you know anyone that's getting this, or maybe a family member, this has that new feature. Heather, did you hear about this? It has a Mayday button. It's in software, but you press it and it actually does like a video call with an Amazon support representative on the freaking tablet. And it's right there. And you get they can draw on the screen, and you can even grant them the permission to take over. Now, probably not something I am going to want, but actually family members, maybe actually.
Yeah.
So if you're going to recommend them something like this, maybe have them use our affiliate link at the bottom of our website before they purchase, or just grab that browser extension just to have it taken care of automatically. And we really do appreciate it. It helps us keep these shows on the air and helps us even out our costs as they come up, which seem to be plentiful. I have learned as a small business person, there's always something around the corner, like the News Bite. Okay, Heather, what are we covering in the News Bite?
Lunar formation and age. One of the leading lunar formation theories is that some big, mysterious planet about the size of Mars slammed into early baby Earth about 4.56 billion years ago, just as the solar system was coming together. And that cataclysm of explosions ended up with the Earth and a whole bunch of debris that ended up coming together and forming the moon.
Right.
New analysis is suggesting it's about 100 million years younger than we thought.
So not necessarily that the whole theory has to be thrown out, but just the timeline maybe has to be adjusted.
Timeline, definitely. There are other theories that are popping up recently.
Uh-oh.
But this is a new kind of timeline, which definitely adds a little bit more to everything. It means that the Earth would have had another 100 million years of development before the giant impact.
Oh, which is significant, isn't it?
Which is how much was starting to form. Was there even possibly a primordial atmosphere develop? And if it did, would that have impact completely blown it away, per se? Or maybe sort of something would have held on afterwards? So it's kind of a big question mark. We can definitely age the solar system. That's from the asteroids, small asteroids, would be, at the very beginning, would have been extensively hit, so you'd have melting from the heat of those collisions. And then once everything calmed down a little bit, those little planetesimals don't have enough heat. They don't have a core in the middle like the Earth does, heating it.
Why wouldn't, okay, go ahead. Well, continue. I'll ask you when you're done. I won't interrupt.
Okay. So you could say, okay, we know this asteroid melted at this point, which means we can say, go back 4.568 billion years. So we can say that is when the solar system was really coming together. Now, when the planets starting to come together, that's still a question mark. Because, they have enough heat in the middle to continue melting. And you could sort of lava on the surface. And so it kind of redistributes the surface of the planet. You're kind of erasing away what's happened and riding on top of it. But you had a question.
Well, I guess it seems like I was watching the demo videos that you linked in the show notes, and it seems like to me there would be so much debris that wouldn't the planet, if it was an impact like this, it seems like we'd have like a ring. We'd have like Saturn type style ring. Where would all of the debris have gone? Because we have a gravitational pull on that stuff.
Yeah, well, it would either have come back to Earth, or just because of the way it was, all that debris would have conglomerated into...
Because it was all hot and sloppy?
Yeah. Now, Saturn's rings are very tiny pieces of ice that are constantly getting hit, and their moons is some of those moons are actually volcanoes of ice water, so they're kind of continually adding to that. But the moon obviously is a nice big chunk of rock. It's not adding anything extra to make a ring per se.
It seems so wild that we can't even quite nail down how our moon was formed. It just shows you that there's still a lot that we got to figure out.
Yeah.
That's in our backyard. Do you think we could dial that one in? I know.
Yeah, it's really hard to read that kind of stuff. The other leading theory that's kind of coming up in the ranks would be that there was, instead of one Earth size, one Mars size, that it would have been two roughly equal planetesimals that smashed into each other. And then that would have formed Earth and Moon. But still, they're just trying to date things. They're kind of moving the formation date of the moon kind of further and further down the line. Now, we think the moon had, global ocean of molten rock shortly after its formation. So we can currently, we're kind of determining the age of those lunar rocks that we have, saying, all right, those rocks that possibly came from that lava ocean early in the moon's history are, this age. And then here on Earth, we can say, all right, we have signs of several locations. The major melting event happening at, 4.45 billion years ago. So now they're kind of like narrowing it down. We're like, okay, we know the moon had a giant melting event here when it was starting to cool down. And we know the Earth had some sort of giant impact event here. So it's kind of closing in and narrowing down as we kind of continue to get better techniques and incrementally, improve our technology.
Mm-hmm. I bet we'll figure this one out. I feel like this is one we can solve. We have we have the power, and we have the ability, the technology, I guess, as they say. Well, very fascinating, Heather. And check out the videos that Heather linked in the show notes. They're really cool, especially that one of them looks like it's like a super high-end CG. It's pretty neat. Well, I got good news. The band is in here. We'll see what they play for us. Let's give it a go. Oh, the 2Byte News.
Yes.
As the band. So what are we talking about in the 2Byte News?
All right, infant blood sugar. There are newborns that have low blood sugar. Sometimes they have to go to the intensive care unit for intravenous infusions of glucose. Now, there's a new study that shows that rubbing sweet gel on the inside of the baby's cheeks can also help with low blood sugar. So there are, when low blood pressure, blood sugar in newborns, neonatal hypoglycemia. It occurs when baby body needs more sugar to meet the energy needs than is available in its bloodstream. So, prolonged low blood sugar runs the risk of neurological injury. Now
Does this happen in the U.S.? Is that possible? I
Yeah.
thought they just gave you a sugar IV when you were born in the U.S. I didn't.
No, not quite. Now, currently they show 5 to 15% of healthy newborns measure low blood sugar in the tests. Of course, doctors don't typically run that kind of analysis. They only run it when they see, symptoms, poor color, seizures, or, all the list of kind of things that happen. Now, a lot of infants with low blood sugar don't actually have those symptoms. So now they're kind of designated, okay, what's the at-risk infants? Preterm diabetic mothers, large, small for gestational age. So it's all these different things that are going, okay, we think these groups of babies have a higher chance, so we'll test their blood. And we see all these babies that we see definite signs of what's happening, so we'll test their blood. But we're not really getting a full view of we know that it is this much percentage because we don't test every baby. So and they did a study where it was 237, apparently healthy newborns. They had one of the risks, or were, feeding poorly or something. Now, half the babies were randomly assigned to get this glucose gel made of dextrose. So rubbed on the inner cheeks about 6 times over the course of 2 days. The rest of the babies got some placebo gel. Now, in the placebo gel group, 30 babies, or about 25%, actually had to go to the intensive care unit for hypoglycemia. In the dextrose group, where they actually were treating it with the sugar, 16 or 13% had to go to the intensive care. So it's half as many. So it had been tried in the early 90s as a rub for infants. It wasn't really fully tested or put into widespread use, but it's sort of coming back. That it's
yeah, and it's seems like a pretty low cost, low impact solution.
Yeah, so you're not having to worry about taking the baby away from the mother, putting it in the neonatal unit, having to worry about IVs, being separated from the mother, having all sorts of various issues that come from that maybe you'll be able to catch a lot of them doing this rub before they have to go.
Now we have another story, don't we?
We do.
The New Horizons Message Initiative. Tell me about this.
All right, so the SETI, the Search for Extraterrestrial Intelligence. Yes, those people. But they've created a petition called the New Horizons Message Initiative, and it's asking NASA officials to upload some crowdsourced message that they don't know yet onto the New Horizons spacecraft. This is the spacecraft that is heading towards Pluto. Now they're saying, all right, what their idea is, after the craft has has gone past Pluto, it's on all of its science data, and all it's doing is just flying out, not doing anything except calling home. They say, okay, well, can you take like 100 megabits of its memory and let us put together, essentially a new golden disk. The golden disks on Voyagers that, had messages, they had hello from Earth and pictures.
We can add it while it's in flight.
Yeah, to be able to upload that and say, all right, here's all sorts of pictures and sounds from Earth and a message or whatever. Now, of course, the program itself, New Horizons, they talked about it before they actually put the spacecraft together and went it out, but they're on tight budget, didn't want to get distracted, so they went, all right, we'll shelve that idea. Now, SETI is coming out and saying, hey, let's put a petition together to ask NASA. Now, it's one of those things where NASA funds won't be used, so the group is kind of asking for private individual funding, and it's going to be possible to do that. Now, of course, they have to wait for NASA to approve or disapprove. So they have to go through all sorts of different steps for NASA to say, yes, now give us your little bit of information and we'll upload it.
Mm-hmm.
But it's just sort of a spark of an idea that they have going. And it's kind of interesting. The fact that it would be crowdsourced, the people will sort of decide what would be in that and try to fund it and move it forward. And all they'd have to do is like, dear NASA, can you mail this letter for us?
Essentially, I guess. Heather, stand by.
Yes.
I've got a flashing light. Hold on a second. The SciByte 2000. Oh, good. It's either incoming communication or self-destruct. I never know. I really got to get that bulb fixed. So we have a little viewer feedback here, don't we?
We do. I got this message in from Nikki, from the Summer SciByte co-host, also over there on Stoked Radio co-host. She sent me a story that was about lightsaber technology. Real science, people. Researchers have found a way to bind photons together like they were molecules.
Photons.
So now,
this is the makings of a lightsaber, ladies and gentlemen.
Yes, now we were pretty sure that, everything we thought about photons, that they're elementary light particles, totally massless, don't interact with each other. Now we're kind of saying, okay, apparently they can. So they took a couple of photons in a cloud of rubidium. This is a chemical metal. So they flashes and then had a cloud of this metal in a vacuum chamber cooled to just a couple of degrees above absolute zero. Of course, this is one of those situations where it's really, really specific, constrained set of things, totally not sitting around in your living room.
That's step one, Heather. That's step one.
Yes. So they were able to shoot a couple of photons into this, and they came out as a pair, like they were a single molecule. So what happened is they started to interact with each other, go as they passed through this medium, so strongly they began to act like they had mass, and that's what made them be able to bind together.
A photonic interaction that's mediated by atomic interaction. Wow. This makes the two photons behave like a molecule, and when they exit the medium, they're much more likely to do so together than as single photons, hence binding them. Amazing. Oh, gosh.
So it's like they're able, one, starts, has energy imparted to it, starts exciting, and then the other photon similarly, so they start pushing and pulling each other. And of course, they want to, this is sort of a new state of matter that they're trying to analyze. Of course, they're thinking quantum computing. The rest of us are thinking, lightsabers. Now,
I was thinking holograms too.
Oh, there you go.
That'd be good.
Well, it's in such a way that they said enough of them together could, hit each other in some way. Heaven's Ringe in the chat room asks if they're totally bound together or do they, separate eventually. It did not specifically state in the article, but my guess would be that they probably would eventually separate, in the fact that this is a specific state of matter and that it only happens in this rubidium cloud at a couple of degrees above Kelvin in an almost absolute vacuum. So once it leaves that kind of environment, then it
show's over,
won't act
folks.
the same.
Show's over.
Yeah.
It just doesn't. Yeah, it can't hold it together, I would think. But maybe, it says once it leaves the medium, they're more likely to stay together. So maybe.
Yes.
Depends on the conditions outside the medium, I would say.
Yeah.
Well, now I know people will ask, and so people probably have asked, hey, how do I get a hold of SciByte?
That's right. Minnie Nessie sent me a tweet asking if I had a Facebook page. Now, SciByte does not have a Facebook page, but you can reach me on my Twitter, as he did, at JB_Mars_base. You can also use the Jupiter Broadcasting contact form. And I do have a Google Plus SciByte going on. It's a link in the show notes. So during the summer SciByte season, I was definitely updating that quite a bit because, the episodes were pretty short, so I wanted to kind of shoot out other stories. I'm not updating it quite as often right now, just because I need to focus on the show notes.
Effort where effort needs to go, Heather. That's what I always say.
Just because these episodes are a little bit longer. Now, I do post things occasionally, but I can't promise how often that might be updated.
Very good, Heather. Very good. Well, links to all that stuff is in the show notes. Hey, I feel like talking about Mars. You ready to do a curiosity update?
Yes.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
Yep.
So, what's going on up there? Well, what's the latest with Curiosity?
All right. They have started publishing some more official data from the, they were hanging around the first area that they were analyzing for about 6 months. So now some of the rover teams are putting out papers about that. And they were able to reveal that the first scoop of soil that they analyzed, the very first, showed about 2% of the soil was water.
Hey, that's good news, right?
Yes. Now, it's not completely new news. Any of the orbiters have seen, hey, we think there's this amount of, water by weight in the soil in these various areas. Now, under the soil, there's been estimates of up to 10 or 12%. Now, the top layer itself would be much drier from, radiation, solar radiation, and things like that. And yeah, so you'd be able to take that top layer, and because of all the wind, it's pretty much more analogous wherever you'd be able to see it. But
so no digging wells yet.
No digging wells yet, but this is the first time we've seen, scooped up, proof.
All right. Okay.
We've been able to estimate it from orbit, but now we actually see, yes, the top layer of soil is there. They're able to see when they took the soil, they dumped it into their little heater. They're able to release some carbon dioxide, some oxygen, some sulfur. They didn't see any organics, but totally reasonable that they wouldn't because of the harsh radiation and oxidants that they see on the surface of Mars. There wouldn't be anything on there.
So we've got evidence of ancient riverbeds. We've got, we find water. I mean, this is, to me, how do you have riverbeds? How do you have water and not have maybe a little bit of life? I mean, I know there's no methane, but I mean, come on, a little bit of life, Heather. Come on, right?
Yep.
You starting to get positive vibes?
That is the question.
You're hopeful. Eventually that thing's going to come across some sort of fossil or something, maybe. I don't know.
Yeah. And they did actually find some further evidence of a different ancient river. They come around the patch of pebbles that had been formed rounded by flowing water, long, long time ago. What was important is that we'd seen it before at that first outcropping. So we said, yay, we saw a river. Here's the size of the pebbles. We know that it was flowing this deep and this high. And now we see it again. But the more interesting thing is that they are different. So that you can see, because they're different, we know that in such a way that we know that they were formed at different times in Mars's history. So as we cross this sort of expanse of Mars, heading to the Mount Sharp, the mountain where it's headed to, we can look at, hey, here's a riverbed, hey, here's a riverbed, kind of plot it out as we go and be able to get a much better idea of where the water was, when the water was over this greater expanse of this crater of Mars.
That's where it'll find the fossil.
That's
my
where
words, Heather. Even if they find it, they won't say anything. No, I can't.
Science is waiting for science.
Yeah, I understand. All right, well, that's what the Curiosity rover's up to. Anything else you want to touch
on? Not right now. Otherwise, that we're just continuing to do the road trek over to Mount Sharp.
All right, well, then jump in the time machine, because here we go.
All right.
Got the new supercharger on here. Runs nice, huh?
Yeah, I put my seatbelt on.
Now, I'm glad we didn't go too far back with the new supercharger, but this only took us to 55 years ago, October 4th, 1958. Heather, what happened this week in science?
Beeps came from the sky. Sputnik, the space-age Soviet Union, to the dismay of the U.S., launched Sputnik, first man-made satellite, into orbit around the Earth, circle every 95 minutes or so, went about 20,000 miles an hour, and
freaked us out.
Yes.
Yeah.
Sputnik merely means companion or fellow traveler in Russian. Launched out of Kazakhstan. Stayed in orbit for about 3 months, then fell from the sky and burned up. But it was, transmitting a radio signal that all it was doing was instrumentation for temperature measurements. But you could, to put a radio...
Which a lot of people had back then, that they could tune in.
Yes, they could point it up in the sky and they could hear it sending out its little tones.
That's only 55 years ago.
Yeah, we had tones coming from the sky that freaked everybody out 55 years ago, and now we're roving around on Mars, scooping up dirt and finding water.
That's right, from there to that. Well, very good, Heather. Let me recalibrate the SciByte 2000, so that way we can look up into the sky this week.
That's right. For the next 2 weeks, you might be able to spot, if you're in a dark enough location, what they call a false dawn, as I put little air quotes in the air. Theater of the mind. It's called zodiac light. It's caused by sunlight scattering about the space dust around the zodiac. So it's the plane of all the planets. They're all in a disk. And at certain points, you can have a whole bunch of dust there, and you can scatter the sunlight off of that. Now, moonlight, light pollution, both are going to knock that out. You're not going to be able to see it. But if you're in a dark enough area, you might be able to see it. And it really looks like, a shine in the sky. Like, oh, wow. What do you mean the sun is coming up at this time?
That is so cool looking. Yeah, that's one of those things where if you live in a really bright area, take a minute to look at the video. It sure is neat. That is so cool. It does kind of look like a sunrise.
Probably only the way most of us are going to be able to see it. But if you're in a dark enough area, then totally let us know if you see it.
Yeah.
And more specific notes, on Friday, October the 4th at twilight, take a peek high in the northeastern sky. You might be able to see a giant kind of squashed W on its end. That is the constellation Cassiopeia. And over in the northwest, you're able to see the Big Dipper lowering into the sky. The planet roundup this week, Venus and Saturn are both low in the west to southwest during twilight. Saturn is much fainter. And on Friday, it's about 17 degrees to the right of Venus. So you see the bright Venus, they're about 17 degrees. Now, if you hold your pinky and pointer finger stretched out, held at arm's length, that's 15 degrees. So if you see the bright Venus, then you can do that to kind of get an idea where Saturn might be. Mars is still an early riser this week. About 3 a.m. local time, going to be rising in the east. Now, right below Mars is a blue-white, quote, star we talked about last week, Regulus. 2 binary stars orbiting each other. Now, on the 5th, they'll be about 6 degrees apart, and 5 degrees, about your 3 middle fingers held together. They'll be about, yay far apart. Now, Regulus is very blue, and Mars is more orangish red, so you can kind of see the color comparison between the two of those. Jupiter is also a night owl this week, rising about midnight over in the east. It's going to end up kind of high in the east to southeast by early dawn.
Hey, that's pretty busy. That's the whole show right there, huh?
Yeah.
There's no way I could keep all that in my head. No way. So if you're like me, go over the show notes, go to jupiterbroadcasting.com, click on SciByte 104, and then everything's great. It's like that's great just on its own. But if you scroll down specifically at the bottom, that's where Heather has all of the keep an eye out for highlighted in the show notes. It's pretty cool, including that video of the dust cloud. All right, Heather. Well, thanks for the great show.
Thank you.
And, of course, thank you, everyone, for tuning in this week's episode of SciByte. Don't forget, we'd love to have you join us live over at jblive.tv on a Tuesday. And now when you go to jupiterbroadcasting.com/calendar, it takes care of the time zone for you. And, of course, you can always download us on Wednesdays. Heather, we'll see you right back here next week, okay?
See you.
All right, everyone. Thank you so much for tuning in this week's episode of SciByte. See you right back here next week.